Okay, good morning. So let's continue with our class on research methods for COMG 302. And yesterday we talked about experiment, which is, if we recall, a quantitative methods that it is designed to specifically reveal causal relationships. Okay, we said that, let's have a quick review. We said that experiments are capable of establishing causality because um, it is able to do three things, two of which survey studies cannot do, right? So we know from a survey we can easily establish that A correlates with B, right? Imagine A and B are two variables. So with survey studies, it is very easy to establish that A correlates with B. We need only two variables, right? A variable that measures A, a variable that measures B. For example, we can measure, to use our example, right, how much time you spend studying, and then we can ask participants to report the GPA, and then we can easily correlate these two variables to see if they will change together. Okay, so that's pretty much what surveys can do in terms of, exploring the relationship between A and B. But experiments can do two further things that survey studies cannot easily do. Um, there are more advanced versions of survey studies that might be able to accomplish part of, what experiments can do, but still, experiments are the method, the only method that can firmly establish causality. Okay, so the two other things that experiments can do, whereas survey studies cannot do, is to establish the time sequence between the two variables, right? We said yesterday that it's very difficult to establish the temporality, of time and GPA in a survey research if we only rely on people's self-reports. And that is, the reason is very simple, right? You might think that as long as we put, for example, this is a questionnaire, right? So you think, well, as long as we put this time variable ahead of GPA, isn't that sufficient to establish, the sequence of these two variables, right? People answer this time question first. I spent 5 hours studying yesterday, and I looked at my GPA today. It turns out it's at 3.5. Isn't that a sequence? Well, we actually mentioned that yesterday, right? You can easily imagine a different scenario. That is, again, you have these two variables arranged as as if the variable time comes before the variable GPA, but the it is very possible that the real psychological mechanism is like this, right? For some reason their GPA is about 3.5. You think, well, it's actually a pretty good GPA. That suggests I must have spent lots of time studying in the past. But you don't actually have, a record of how many hours you spent studying in the past. So you make a guess. You think, well, because I have a good GPA, that suggests I must have spent quite a bit of time studying. So maybe 8 hours a day. You see, in this case, your real psychological sort of process is actually, reversed, right, compared to this one. And therefore, it is very unclear and very ambiguous from a survey study like this whether time costs GPA or GPA causes how much time you spend to study, right? And that's a very reasonable hypothesis because, it is very common that if you have a good GPA, you're more motivated. And once you're more motivated, you start to spend more time studying. Conversely, if your GPA is low, you lose all the motivation and you don't want to study. Instead, you go to play Pokemon Go. Okay? So that's a totally reasonable hypothesis that instead of time causing GPA, it's actually GPA causing study time. So a survey study based on self-reports really are not able to establish whether the cause, right? So if we want to say it is A cause B, right? In addition to establish the fact that A and B are related or correlated, it is also very important, essential to establish that indeed A, the cause, precedes B. Right? So a survey study like this cannot do that. But experiments can do that because we talk about the features of a properly conducted experiment. And it is the idea that, in experiment, we also have two variables or two classes variables. The first type of variables are independent variables, right? IVs. And the second type of variable, the variable to be explained, dependent variable, right? DV. We said that, sure, we can use questionnaires to measure the dependent variable, but almost always we do not use self-report to measure independent variables, right? So to measure independent variables, we provide a scale to participants and ask them to choose a number, to give the number to the independent variable, right? So Andrew would say, well, on this independent variable, I will give it a 5. The respondent, in other words, if you provide a scale to respondents, then it is up to the respondent to provide a value to the independent variable. But in experiment, it is the researcher who decides what the value or values the independent variable should take. So in this example, for example, if we really would like to establish the effect of time on GPA, that is, if we really would like to establish that it is time causes academic performance, then what you should do as an experimenter is to create two groups, right? You create two conditions, in other words. In one condition, you force people to study 10 hours, assuming that it is doable. And in another condition, you force people to study 5 hours per day. No more, no less. No more, no less. No more, no less. Right? So as such, this independent variable time will take two values, 10 versus 5. So it becomes a variable, right? Because there are two values, they're different, so it's a variable. And then you put people right into these two conditions, and they're different people. So imagine you have 10 people here, you have another 10 people here. These 10 people only study 5 hours per day, and these people only study 10 hours a day. Okay, and then you give them, each group of participants, the same tests, right? Tests, tests. And of course, these two tests are identical, right? You cannot give this group a more difficult or easier task because that will surely bias the result, right? You want to give them the same test. So after that, you can have a average score. Let's call it x1, right? From this test. And from this test, you will have a second average score, x2, right? From these 10 people. x1 will be from these 10 people. And so you would compare, as the next step, which average score is larger, right? With a larger score indicating better academic performance. Okay, so you plot these two scores. You say, well, this is time spent studying. This is score, right? And then you have the 10-hour group, you have the 5-hour group, and you see, well, indeed, right, after calculating the average scores, you indeed the 5-hour, people from the 5-hour group scored higher on this test than people from the 5-hour group. Then you can, you know, establish that it is indeed the case that time causes academic performance. But if you really have to paid attention to the class yesterday, you might notice that I missed something, and that is there are no alternative, you know, um, causes to B, right? So A is the presumed cause, B is the intended effects. So the third criterion of establishing causality is that there are no confounds, right? There are no confounds or alternative explanation to B. So we cross them out, right? So there are no confounds to B. We have to rule that out. So, a reviewer looking at this graph might say, well, wait a minute, Andrew. Is it possible that, the people who you put into the 10-hour group happen to have, higher IQ than the people you put into the 5-hour group? In other words, is it possible that these group of people have higher academic performance scores than this group of people simply because this group of people are smarter? Okay, it is possible. All right, so from the lecture yesterday, we know that we have a way of avoiding this from happening. And that is, in more general terms, with a way to rule out the potential confounding effects of individual differences. That is, personality traits or any kind of traits that differ across individuals, right? And we know that the method of ruling this confounding effect of individual differences is called randomization, right? It's R. In other words, in this case, right, you have 20 people from this subject pool, right? You have 20 of them. So what you will do then, as the simplest method, is you will flip a coin. You decide before you flip the coin that if it's heads, then you will go to the 10-hour group. If you have a tail, then you go to the 5-hour group. Right? This is not low. This is 10. Or the other way around. It doesn't matter because this does whatever number you correspond to heads or tail does not matter because the result you will get from flipping a coin will be random, will be unpredictable, right? So you start flip a coin, you flip the coin. For the first time you have a head, so the first person will be here. You flip it again, you have another head, that's okay. You go here. But then later on, eventually you will get, some tails, and whoever gets the tail will become here, right? So if the sample is large, instead of 20 people, you have 20, 200, or even 500 people, then this randomization process by flipping coins, right? By randomly, assign each individual to the two conditions, you can be pretty confident that the average intelligence level or any other personality traits will be roughly equal across the two conditions because what you did is you randomly put people in the two conditions, right? So you might have some very intelligent people here, but you might have some, not so intelligent people here. The same will happen in this condition, right? So that's how we sort of rule out the potential confounding effects of individual differences. Another very important point or practice of ruling out confounding variables is to make sure that your manipulation is clean, right? So here we said that we have one manipulation, and that is, time spent studying. Um, if our goal, right, is to simply demonstrate that it is indeed time that causes academic performance, then you should keep all other elements in this experiment constant or comparable between the two conditions, right? You should put them into identical rooms with similar lighting, with the same temperature, with the same studying materials. You should talk to them the same way, etc. Right? Anything that you can think of that might have any effect on their test score, you should keep those elements constant or equal between these two groups. Only by doing that, right, can you be confident in saying that, well, because everything else are the same, and the only changing factor in this experiment is time. And because of this change, we observe some differences. Then it must be the case that time causes the intended effects, that is, the improvement of academic performance. Okay, so that's the logic of experiments. So also yesterday we said that we discussed some terminologies. So we say this is an independent variable, right? The variable that represents the presumed cause. And what researchers will do in an experiment is it will manipulate, that is, artificially change the values of the independent variables, right? So in this case is make people study for different amounts of time. Um, and we also said that we usually call independent variables factors, right? Factors in the context of experiments. So factor in experiments is the same thing as independent variable, right? So with a factor, we can, through manipulation, create different conditions, right? We can create three conditions. Here we have two conditions, but there's no reason why we cannot create three conditions, four conditions, 10 conditions. But usually three is a good number, right? Two is the classic number. Three is okay. But if you have one factor that has four conditions, that might be problematic for reasons that we'll not discuss in this class. But typically, two or three conditions are very common. Okay, so if you have one factor and three conditions, or three levels, right? You have three levels for this factor: level 2, level 3. And these levels or conditions are actually the values that this factor or this independent variable will take, right? So in this case, it takes two values. The independent variable time takes two values, 10 hours and 5 hours. Here it takes three values, and of course what these values are depend on what the researchers you know really does in the experiment. It could be that in condition 1 they make everybody study for 10 hours. In condition 2 they made them study 15 hours. Condition 3 they made them study for 5 hours, right? So now this factor or independent variable takes three values, or has three levels. Okay, and in each level we can obtain a mean score, right? X1, X2, X3, because we typically put multiple people into each condition, right? 15 here, 20 here, 20 here, 20 here, right? Each person provides a score. We have 20 scores here. We can easily calculate an average. The same thing here, right? And then we can compare the averages to see which average is the highest, which is the lowest, and use that information to verify whether our hypothesis is supported or not. Okay, so this is the idea of a single factor multiple condition between subjects design. It's called between subjects because we're comparing, right, across conditions which has totally different participants, right? These 20 people will only be in this condition but not in the other two conditions. Same thing will happen to these 20 people and these 20 people. In the end, we compare the differences between, right, each group of participants, and that's why it's called between subjects. Subjects, it's just another name for participants. Okay, so that's a review of the previous class. It takes a bit of time, but I think it's worth the effort because experiments has the topic has many terminologies that we do not use in daily life, and therefore you're not very familiar with the logic or the terminologies for this particular method, and therefore it's a good way or idea to keep refreshing our memories. And that will lead to our discussion of further topics in experiments. That is, previously we only talked about situations or experiments that only have one factor or one independent variable. But the question is, what if we have more than one independent variables? So the example that we used in yesterday's class is we want to study how people perceive others, perceives others' friendliness. We said that, one experiment we can do is we manipulate the target person's interpersonal warmth, right? We said this person is warm. We describe this person as warm for one group of participants. We describe the same person's cold for the second group of participants. So we have a warm condition with a cold condition, and these two conditions are the two values for this variable interpersonal warmth. And we have two groups of participants, right? Each reading their own description provides two average scores on how friendly Mike is, right? The target person is, and we'll compare these two average scores to see whether it is indeed the case that a warm person is perceived as more friendly, right, than a cold person. Okay, so that's a single factor, right? This is interpersonal warmth. Okay, so this one factor experiment that has two conditions. But now you're thinking, okay, wait a minute. How we perceive um, a person's friendliness um, might not be just relevant to the warmth of that person. It is possible that we tend to perceive a more competent person as more friendly, for whatever reason, or we're just making this up. Doesn't matter. Okay. You're thinking, well, maybe then the competency of this person will also have some effect on a person's perceived friendliness. How do we know? Okay, and more importantly, we want to know whether a person's competency would be combined with this person's warmth and jointly influence the person's perceived friendliness. Okay, what do we do then? Okay, so the starting point is very easy and similar, right? So we proceed as such. First of all, we perform manipulations to each factor, right? Treating them as independent, separate factors, which is true, right? In the personal warmth. So as usual, we describe this person as warm or cold. But at the same time, we have a second factor here, right? So there's one factor, one independent variable, a second factor, a second independent variable. And we said that, okay, so the easy way to describe a person's competency is to say that this person is competent or to say this person is incompetent. And then, of course, in the end, after participants, read our descriptions, we ask them, how friendly this person is. Okay? All right, so now let me ask you, given this, design, how many variables are there in this design? How many factors are there in this design? And how many experimental conditions are there in this design? Okay? All right, you should actually really pause here to think about these three questions. But to save time for the clip, I would just, describe the answer. But I strongly suggest you pause for a while, think about it, answer these three very easy questions first, compare your answers to mine, and then listen to my explanation. Okay? So the first question is, how many variables are there in this experiment? The answer is, I bet many of you will say two, which is wrong. There are in fact three variables here. This is one variable, right? We just said that there's one factor or one variable representing one presumed cause of how we form impression about a person's friendliness. So that's one variable. We have a second variable, right? We also thought because we also thought a person's competency would also cause our impression formation on that person's friendliness. So this is a second variable. So we have two independent variables here, right? Two factors. But where's the third variable? Well, the third variable is, of course, the dependent variable, right? The variable we're trying to explain. The reason that we conduct this experiment is because we want to know, what causes the variation in our perception of a person's friendliness. Why do we perceive someone as friendlier than other, right? And so this is our third variable. So there are three variables. How many factors? The answer is two. Because factors are the same thing as independent variables. We just said we have two independent variables here, right? So the two independent variables representing the two presumed causes of the effect here. So two factors. How many conditions? Answer is four. But which four? And I bet many of you would say, well, look, condition 1, condition 2, condition 3, condition 4. Wrong. Okay? So when you answer this question, you should really think back to the homework question, or the example that we talk about in stratified sampling. That is, if we want to stratify the population according to their gender and according to their party affiliation, how many strata should we create? The reasoning is the same, right? So here we should have four conditions, but not warm, cold, competent, incompetent. Instead, the four conditions can be easily represented by what we call a 2 by 2 table. Okay? So imagine on this side we have the warmth variable. Okay? And we know for the warmth variable we have two conditions, warm, cold. Sorry, this is cold. Here we have the competency variable. Right? For the competence variable, we similarly have two conditions, competent, incompetent. So the four conditions are formed by each of the two levels of these two variables, factors. So condition 1 will be this person is warm and competent. Condition 2 will be this person is cold and competent. Condition 3 is this person is warm, incompetent. Condition 4 is this person is cold and incompetent. So 1, 2, 3, 4, 4 conditions. Okay? So make sure you understand why the answers are 3, 2, 4 for these three questions, because you bet there will be exam questions like that. Okay? So with this design, with two factors, simultaneously considered an experiment, we'll call this a between subjects factorial design. Okay? So previously we said that we have single factor between subject design, but now we have between subjects factorial design. In a typical factorial design, between subject factorial design, we have participants assigned two conditions formed by two or more than two independent variables. Right? Factors are just another name for independent variables. So there are many ways to describe a factorial design. So, from now on, we occasionally will omit between subjects because for this class, we'll only talk about between subject design. Okay? So how do we describe a factorial design? So bear with me right now. Okay? This might be very novel to you, and but once you understand the logic, it's very straightforward. The logic's very straightforward. So we'll describe a factorial design using our example that we just described in the previous slide as a 2 by 2 between subjects factorial design. Right? Because, as we said just now, we have two conditions for the first variable and two conditions for the second variable. And these two conditions, and these two conditions, together they form a four-condition design. Okay? So that's why we said here it's a 2 by 2 expressed as 2 times 2. And we know that 2 times 2 equals to 4, right? So that is consistent with our sort of schematic representation of this design. So the first two here represents the number of conditions, right? Well, first of all, this whole thing, right? 2 parentheses warmth, warm slash cold represents our first factor. We call it warmth, okay? So warmth is the name for our first factor. And it has two conditions, warm or cold. Now we have a second factor. Its name is competency. It has two levels, competent or incompetent. Okay? So these twos, as we just said, are the number of conditions in each factor. Okay? Not very difficult, huh? Once you understand, what each component means in this, sentence. Okay, so as we just said, now we have four conditions, right? If this could remind us the design using the table method. So we have warm, we have cold, we have competent, we have incompetent. So of course we can have we have four conditions. In the first condition, we describe Aaron as warm and competent, right? And then we have a second condition in which we describe Aaron as warm and incompetent. So it will be warm, incompetent. This will be condition 2. Aaron is cold and competent. So Aaron is cold, warm, cold, competent. So condition 3. Aaron is cold and incompetent. Condition 4. Okay, and then the dependent variable is how friendly is Aaron. So we can imagine that we'll put 30 people here, we'll put 30 people here, put 30 people here, we'll put 30 people here. So for each condition, we can have an average score, right? Because for these 30 people, each one of them will provide a score on a 7-point scale, for example, right? To describe how friendly Aaron is. So these 30 people provide 30 scores, and we can compute an average based on these 30 scores. So we have one score, a second score from the second condition, and two more scores from the remaining two conditions, right? And then we can compare, in which condition they would perceive Aaron as the most friendly. Right? So now we should be rather familiar with this graphic design. Okay. Alright, so now we should have a pretty good understanding of what this table means, right? With four conditions formed by the two factors, each of them having two conditions or levels. So here we describe Aaron as warm competent, here we describe Aaron as cold competent, here we describe Aaron as warm incompetent, and here we describe Aaron as cold incompetent. Okay, now here's my question. How do we assess the effect of the warm cold manipulation given this design? In other words, how do we know, what scores, in each condition, right? We said that because we have multiple participants in each condition, we can easily calculate 4 averages from each of the 4 conditions. Then my question is, well, the question, an equivalent question to this one is, what averages do we compare to determine whether the warm-cold manipulation will indeed produce different scores on Aaron's perceived friendliness? That's my question. Okay? So to help you understand and answer this question, let me rewind a little bit and reconsider, right? A situation that you only have one factor, warmth, and 2 conditions, warm, cold. So we know, and of course we put 30 people here, we put 30 people here, right? So that we have 2 average scores representing these 2 group of people's perception of Aaron's friendliness. So with this design, it's very easy, right? To know whether or not this warm-cold manipulation will produce any difference in Aaron's perceived friendliness, we'll simply compare these 2 averages, right? Want to see whether x1 is higher than x2. And if this is the case, then we'll say that the warm-cold manipulation is working, right? It produces an effect, so to speak, on the target person's perceived friendliness. Okay, so if this is, our way of comparing mean scores in a one-factor experiment, then what do we do with the 4th score here? How do we know then, given this design, the warm-cold manipulation is working? Right? How do we assess the effect of this manipulation? Relatedly, we can ask, how do we assess the effect of the competency manipulation? Right? How do we know that by describing Aaron as competent or incompetent, we're affecting participants' perception of Aaron's friendliness? Okay? And lastly, how do we assess the joint effect of the 2 manipulations? That is, how do we know, for example, whether Aaron will be perceived as the most friendly when he is described as warm and competent, and he will be perceived as least friendly when he's perceived as incompetent and cold, right? How do we do that? Well, then what about when Aaron is described as cold competent, and when he is described as warm incompetent? How do we assess the joint effects at once, right? Okay, so the remaining part of this class will focus on answering these 3 questions. And to answer these questions, we need to understand 2 types of effects in more general terms. So, in more general terms, when we say that, a manipulation has an effect, we mean that this manipulation results in differences across the conditions on the dependent variable, right? So if we stick, to this one-factor design here, warm, cold, right? This is a manipulation, right? Describing Mike or Aaron as warm or cold, right? So if we have 2 average scores, and these 2 average scores are different in the intended direction, right? The warm Mike is perceived as more friendly than the cold Mike. Then we say, right, this manipulation resulting in the difference across these two conditions, then an effect is present. Conversely, right, if this manipulation, in this case warm coat manipulation, does not result in any differences across these two conditions, then we say an effect is absent. There's no effect. Okay? So now we're ready to talk about or define main effect. Main effect is only relevant when we have multiple factors. That is more than one factors. Okay? And main effect is defined as if a main effect is present, then that suggests there is an effect of one factor across all levels or all conditions of a second factor. That is, there's a difference in marginal means. You will say, well, hang on, Andrew. I don't understand any single word you just said, or on this, two sentences. That's okay, right? And that's what the next slide is for. So let's return to this 2x2 table, okay? Formed by the two factors, competency and warmth, each of them having two conditions: warm, cold, competent, incompetent. And we say that we put 30 people into each of these conditions, and each group of people will produce one condition mean, right? This one condition mean for this condition, or average, means just another word for average. Condition mean for condition 2, mean for condition 3, mean for condition 4. So let me first ask you, how many conditions make up the warm condition? So here's the warm condition. What does the warm, how many conditions does the warm condition have? Or, among the 4 different conditions, how many belong to the warm condition? Another way to think about it is, among these 4 conditions, in what conditions you will hear the target person described as warm? The answer, of course, is 2. We have Aaron described as warm, competent, warm, incompetent. Even though, right, Aaron is described differently across these 2 conditions, that doesn't matter. There's one common element here, that is, he is described as warm across both conditions. So the answer is, there are 2 conditions that constitute the warm condition. Similarly, how many conditions constitute the cold condition? In other words, in what conditions in this experiment is Aaron described as cold? Answer is very easy. In these 2 conditions, right? In this condition, Aaron is described as competent and cold. In this condition, where's my cursor? In this condition, Aaron is described as cold and incompetent. Then we have 2 marginal means. Means at the margin. Not in the cell, but at the margin. With 1 marginal mean, we have 2 marginal means, and the main effect of warmth, that is, the difference between the manipulation, the difference between the warm condition and the cold condition, which constitutes the warm variable, will be the difference between marginal mean 1 and marginal mean 2. That is, the overall mean across these 2 conditions and overall mean across these 2 conditions. Okay? So in other words, it will be the mean for condition 1 plus the mean for condition 2 divided by 2, right? This will give you the average of these 2 averages, right? There's one average, two average. Now we want to know the average of these two averages. So C1 plus C3 divided by 2. Similarly, marginal mean 2 will equal the mean for condition 2 plus the mean for condition 4 divided by 2, right? The average of these two averages. One average, two average. The average of these two, you sum them up, divided by 2 because there are two of them. Okay? So this will give you the effect of warmth. Right? Once we have concrete numbers, then you can substitute concrete numbers to C1, C2, C3, C4 and have a concrete number, right? Whether, marginal mean 1 is indeed larger than marginal mean 2. If, you have marginal mean 1 larger than marginal mean 2, that suggests, if, larger scores means more friendly, right? Then we'll say indeed, right, independent of competency, right, a warm person is perceived to be more friendly than a cold person. Okay, so that's how we interpret main effects as well. Then similarly, we can figure out the main effect of competency. Well, first of all, right, we know that competency, this variable, has two conditions, competent and incompetent, right? But because we also have a second factor, which has two conditions, excuse me, we can't just say, oh, this is, this score represents Aaron's perceived competence when he's described as competent, because we also have another condition, which will also contain any effect of competent, because in this case, in this condition, Aaron is described as cold and competent. So similarly, right, we'll have these two conditions constituting the competent condition, and similarly we have these two conditions constituting the condition of incompetent. So accordingly, we will also have two marginal means at the margin, right? Not means in the cell, but means at the margin. Okay, so similarly then, we can compare these two means to assess whether, right, the score for Aaron's perceived friendliness will be higher than the score for Aaron's perceived friendliness in the incompetent condition, right? That is, we'll compute the difference between these two mean scores. And of course, we can sort of work out the formula very easily between these two means. That is, because marginal mean 3 will be the mean between these two averages, right? So we have C1 plus C2 divided by 2. That will give us this marginal mean. And then we can use, C3 plus C4 divided by 2 to, represent this marginal mean. And then we work out if there's any difference here, right? If marginal mean 3 is larger than marginal mean 4, that suggests the person described as being competent, right? Regardless whether he is warm or cold, because it's a mean, right, across these two conditions, right? Regardless whether this person is warm or cold, as long as this person is considered as competent, this person will be perceived as more friendly than when this person is described as incompetent. Okay? So, as a general rule then, right, to determine main effects, we compare marginal means, right? So if we compare these two marginal means, we will be determining whether or not competency has any effect on a person's perceived friendliness. And if we compare these two marginal means, we'll be determining whether warmth has any effect on a person's perceived friendliness. Right? So as long as there's a difference between each pair of marginal means, right, between this pair, between this pair. So as long as there's difference, we say that a mean effect exists. Well, please note that we don't compare marginal means like this, right? We don't compare 2 and 4 or 1 between 3 for reasons that we'll not discuss here, but just remember we'll only compare marginal means at the same, sort of margin, right? Margin here, right? Okay. Now, let me ask you, let's see if we really understand the idea here, right? How many main effects there will be maximally given this design? That is, at most, how many main effects we can expect given this design without any scores here, right? So you can pause here to think about answers, but I will just proceed to give you the answer and explain why. So imagine you have paused and then resume, right, with your own answer ready. So the answer is 2, right? At most, we can expect 2 main effects given this design because why? We have 2 factors. Each factor could, right? Remember, I said could. Each factor could have a main effect. Whether or not this main effect actually exists, we don't know at this point. But as long as we have a such design, we would expect 2, at most 2 main effects. One main effect for warmth, the second main effect for competency. Okay, so that's our expectation at most. Now my second question for you, now I give you these 4 numbers. Then how many main effects actually are there in this design? That is, how many main effects do we actually observe given these numbers? Okay, now you should pause here and work out by yourself. But again, to save time for the clip, I will just go ahead and describe the answers to you. Okay, so more specifically, we can ask, what are these main effects? Or, if there's only one main effect, what it is. So remember, in the previous slide, right, how do we work out main effects? So let's say we want to work out whether or not there's a main effect of warm. That is, we want to know whether this manipulation between warm and cold will produce any difference in terms of a person's perceived friendliness. Okay, friendliness. On a scale from 1 to 7, with 7 as very friendly, 1 as not friendly at all. Okay, so here 7, 5, 6, 6. So these 4 scores are the 4 condition means, right? 7 is the mean for this condition, warm and competent. 5 is the mean for this condition, right, when Mike or Aaron is described as cold and competent, etc. Okay, so let's say now we wanted to determine whether or not there's a main effect for warmth. How do we do? Well, as we just said, right? So let's figure out how many conditions are there constituting the condition of warm, the warm condition. Well, very easy. There are 2, right? These 2, because in both these conditions, Mike is described, or Aaron is described as warm competent, warm incompetent. So these 2 numbers, even though they also contain the effect of competency, but both contain the effect of warm. Okay, so we can work out the marginal mean very easily. It's 7 plus 6 divided by 2, that's 3. 13 divided by 2, that's 6.5. Now we can similarly work out the marginal mean for the co-condition, because the co-condition is consisted of these 2 conditions. Okay, so we have 5 plus 6 divided by 2. There are 2 of them, right? So it's 5.5. Okay, so what is 6.5 divided by 5.5? That is 1. Fantastic. There is indeed a difference between these two marginal means. That suggests, right, when Aaron is described as warm, regardless whether this person is competent or incompetent, Aaron will be perceived as more friendly than when Aaron is described as cold, because 6.5 is larger than 5.5. There is right, positive 1, so there is at least one observed main effect. Okay, then is there a main effect for competency? So to work out the main effect for competency, we'll work out these two marginal means, right? So these two marginal means, the marginal mean for competent will be 7 plus 5 divided by 2. That will give us 12 to 6. The last marginal mean, 6 plus 6 divided by 2, that's 6. So what is 6 minus 6? That's 0. That suggests, right, regardless whether this person is warm or cold, but the manipulation of competency, that is, a person can be described as competent, or a person can be described as incompetent. But regardless, right, the description, competent or incompetent, the person will be perceived as equally friendly. In other words, the manipulation of competency does not have any effect on a person's perceived friendliness. So 0 means there's no difference. In other words, there's no effect, right? So here there's only one observed main effect. Despite that, there could be two, right? And the main effect is warmth, right? Okay. We'll scratch this, right? Okay. All right. So here, there's some exercise for you, which I hope you could complete. I might consider actually making them your homework. So let me find out later, right, after this class. Okay, so after we learn about what is, what a main effect is, now we can consider what interaction effect is. Interaction effect describes the joint effect of two factors or more than two factors in one experiment. So interaction effects are defined as, or will occur when the effect of one factor or one IV on the dependent variable is moderated by the effect of another independent variable. You might say, well, that sounds familiar because I seem to recall we've talked about moderation in a previous class. You're right, right? And that's when we discuss, the different types of relationship between two variables or more than two variables, right? Is that? I believe one example is, income would positively predict people's happiness in one country, let's say in the US, right? But income does not predict a person's happiness in another country, China, for example, right? Well, of course it does in China. We all love, having more money, but let's, make this up for the purpose of this, example. So here is moderation, because, obviously the two effects are different, right? Depending on, the effect of income on happiness is different depending on the effect of another variable, which is country here, right? Country is not a variable. It takes the value of USA or the value of China. So in USA, there's a positive effect of income on happiness. As people make more money, they're more happy. But in China, this effect is absent, right? Regardless you make, how much money you make, you can make very little money, a lot of money, but your happiness score does not change. Okay? So this is exactly what we mean by interaction effects. In other words, income and country, these two factors, they interact to impact a person's happiness. So when an interaction effects are present, you know, you might ask, well, then how do we know, right? Actually, of course, we can make this up and plot, these two lines, but how do we work this out with numbers? And whether there's a general rule that we can use to work out the presence or absence of any interaction effects. Well, actually there is, and it's quite a mouthful, and be prepared. So we say when an interaction effect is present, the following must be true. That is, the effect of one factor in one condition of the moderator differs from its effect in another condition of the moderator. What is this? Okay, don't worry, let's work this out. But first of all, let's sort of dissect the sentence. The effect of one factor. This actually should be rather familiar to you now. Because if we go back to a single factor two condition design, right? Warm code. We know we can easily work out whether or not this factor warmth has any effect. We simply compare the two averages from these two conditions that constitute this factor warmth, right? Warmth. If these two, averages are different from each other, then we say, well, there is an effect of this factor, right? This factor. So that's it, the effect of one factor. All right, then what about this sentence? In one condition of the moderator, and that is different from its effect in the condition, in another condition of the moderator. Well, first of all, we should know that moderator is just a variable, like country. And here the country has two conditions. One is USA, second is China, right? So the variable, of course, will at least have two conditions, two values. That's the first value of this moderator, this variable, and that's the second value of this moderator or this variable. So this sentence simply means the effect of one variable will be one thing. Let's say the effect of variable in one condition of the variable, let's use, I don't know, y here, okay? So let's say the effect of one factor in one condition of the variable, let's denote that as y1, and let's denote the effect of one factor, right, its effect, in another condition of moderator as y2. So this sentence simply means if there's a difference between y1 and y2, then we have a moderation effect, or we have an interaction effect. Simple, huh? Okay, let's be more concrete. So let's consider this 2x2 designs. First of all, let me ask you, how many factors there are? Answer is 2. One factor, 2 factors. How many conditions are there in each factor? In each factor, right? So for the warmth factor, it has 2 conditions, warm, cold. For the competency factor, there are also 2 factors, competent, incompetent. So the answer is also 2. So the effect, so let's now dissect the sentence in relation to that design. Presence of the interaction effect. The effect of one factor in one condition of the moderator differs from its effect in another condition of the moderator. So now let competency be the moderator, right? Moderator. It has 2 conditions, competent, incompetent, Okay? So then let's see the part of the sentence that it just, make red. The effect of one factor in one condition of the moderator. Now we know the moderator is competency, and one condition of the moderator could be competent. Okay? Competent is one condition of the factor competency. So this sentence simply asks, then what is the effect of the factor warmth in the competent condition? What is the effect of warmth? That is there any difference between warm and cold in the competent condition? Aha, you would say there should be, because in the competent condition, the warm Aryan is given a 7 for his perceived friendliness, and the cold Aryan is given a 5 for his perceived friendliness. So yes, there is. There is an effect of warmth in the competent condition. In other words, there is a difference in his perceived friendliness when he is described as competent and, with regard to the effect of warmth manipulation. Right? So warm minus cold, 7 minus 5 when Aaron is competent is 2. There is indeed an effect because there's a positive score here. Right? There's a different score here. Okay. Now let's look at the blue part of the sentence. Then what is the effect in another condition of the moderator? The moderator is competency. And we just looked at the effect of warmth in the first condition of moderator, that's competent. Then another condition of moderator will be incompetent. So the question becomes, what is the effect of the factor warmth, or the difference between warm and cold, in the incompetent condition? You would say, aha, we should find that out by subtracting 6 from 6, because that will be the effect of warm versus cold in the incompetent condition. Turns out the effect here is 0, because, 6 minus 6, that's 0. Is 2 different from 0? How do we get the 2? That's the effect of warm versus cold in the competent condition. 7 minus 5, that's 2. 6 minus 6, that's 0, and 0 is the effect of warm versus cold in the incompetent condition. Is 2 different from 0? 2 minus 0, that's 2. Of course, these two are different. So, yes, when the effect of warmth in the condition of competent differs from the effect of warmth in the condition of incompetent, there is an interaction effect. So yes, warmth interacts with competency to influence Aaron's perceived friendliness. Okay, so that's how we work out whether or not there is a interaction effects given a 2 by 2 design. So here is how we can verbally describe this interaction effect, right? So a warm individual is perceived to be more friendly than a cold individual only when this person is described as competent. When this person is described as incompetent, being warm or being cold does not influence the person's perceived friendliness because these two scores are exactly the same. Okay? And interaction effects, if we follow the same logic, are said to be absent when the difference between the cells are the same, right? So if, imagine, right, we have this design here, right? So the difference between these two cells, okay, the difference between these two cells is 1. the difference between these two cells is also 1. 1 and 1 are the same, so there's no interaction effect. You can also work out in, in this direction. Difference between 7 and 6 is 1. Difference between 6 and 5 is also 1. 1 minus 1 is 0. There's no interaction effect. Okay? So in other words, interaction effects are present if the differences between cells, the differences between the cells are different, then we have interaction effects. If the differences between cells are the same, like this, we don't have any interaction effect. Okay, isn't this cool? I hope it is. All right, so now again, I have several exercises for you. Okay, you should work out whether or not you have main effects and interaction effects. Okay, so I believe there's another assignment to be due very soon. And please bear in mind when you submit your assignment, make sure you save your assignments as MS Word files, .doc or well, preferably .doc, because my computer cannot open page files. Okay, thank you, and I will see you next week.